Hello, this is the assignment for numerical method KE36903. We are from group 2. Before that, I like to introduce myself and my friend. My name is Jessel Mojical and my friend is Kutta Oliver. Our assignment title is Runge Kutta method. According to Muhammad Amirul Islam 2015, he claimed that this method was devised by two German mathematicians, which is Runge about 1894 and extended by Kutta a few years later. The Runge-Kutta method is most popular because it is quite accurate, stable, and easy to program in a computer. Runge-Kutta method achieved the accuracy of a Taylor series approach without requiring the calculation of higher derivatives. This is the general formula for Runge-Kutta. yi plus 1 equal to yi plus pi in bracket xi yi h times h. Pi equal to a1 times k1 plus a2 times k2 plus until plus an times kn. Pi in bracket xi, yi, and h close bracket indicate that it's an increment method. As you can see here, the a is a constant. The value of k1 is equal to function of xi and yi. Next, the value of k2 is equal to function of xi plus p1 times h and yi plus q11 times k1 times h. For the value of k3 equal to function of xi plus p2 times h and yi plus q21 times k1 times h plus q22 times k2 times h, where the value of p and q is a constant, same goes to a. Until the highest order of k, which is kn, is equal to function of xi plus pn minus 1 times h and yi plus qn minus 1 dot 1 times k1 times h plus qn minus 1 dot 2 times k2 times h plus until plus qn minus 1 dot n minus 1 times kn minus 1 times h close bracket is equal to function of xi plus pn minus 1 times h. The recurrence relationship, which is k, will appear in the equation for k2 and will again appear in the equation of k3, and so the fourth terms. The formula for fourth order Runge-Kutta is related to this article. According to Nur Ain Ayuni Sabri and colleague 2013, they claim that formula are yi plus 1 equal to yi plus 1 over 6 times in bracket k1 plus 2 times k2 plus 2 times k3 plus k4 close bracket and time h. The value of k1 for the fourth order Runge-Kutta method is equal to function of xi and yi. K2 is equal to function of xi plus 1 over 2 times h and yi plus 1 over 2 times k1 times h. For k3 is equal to function of xi plus 1 over 2 times h and yi plus 1 over 2 times k2 times h. And lastly, for the value of k4 is equal to function of xi plus h and yi plus k3 times h. Now we're gonna see how the Runge-Kutta method was applied. According to Anup Suhar, 2013, he claimed that transient analysis of electrical circuit using Runge-Kutta method and its application. Introduction of this application, transient analysis starts by writing the circuit equation using a basic concept of KCL, KVL, node voltage analysis, and mesh analysis. Due to the involvement of integral and derivative in current voltage relationship for inductance and capacitance, then the integral differential equation, which converted to pure differential equation by differentiating with respect to time. So this is the example of the circuit, the RLC circuit diagram. As you can see here, the equation for the RLC filter is described as a second order circuit. I in bracket t close bracket is equal to C dot delta VC in bracket t close bracket t over delta t. C is for capacitance, VC is the voltage across the capacitance. KVL equation for the circuit is L delta I in bracket t over delta t plus R times I in bracket t plus VC in bracket t equal to V in. We substitute the equation of I in bracket t and then we get L times C times delta power of 2 times VC in bracket t over delta power of 2 in bracket t. For the case of the series RLC circuit, these two parameters are given by alpha is equal to h over omega naught and omega naught is equal to 1 over square root L times C, where the omega naught is the natural frequency. For damping factor in the series of RLC circuit, the equation is the damping factor is equal to R over 2 times square root C over L. Now we're going to see how the Runge-Kutta method is formulated in the example. The Runge-Kutta method uses the formula which is Tk plus 1 equal to Tk plus H. Next is yi plus 1 is equal to yi plus in bracket k1 plus 2 k2 plus 2 k3 plus k4 close bracket over 6. For the value of k1, the k1 is equal to h times function of ti and yi. And the value of k2 is h times function of ti plus h over 2 and yi plus k1 over 2. K3 is equal to h times function of ti plus h over 2 and yi plus k2 over 2. And for the k4 is equal to h times function of ti plus h and yi plus k3. So now f1 is equal to h times function of t, x1 and x2. And for g1 is equal to h times function of gt and x1 and x2. By using the previous equation, we can get the value of f2 and g2 and so on. As you can see in the equation, the G is become the recurrence relationship. The voltage equation across second order RLC circuit is given from the previous equation. Now we see the I in bracket T is equal to C times delta V C in bracket T over delta T. And then now that I in bracket T is equal to X1 and VC in bracket T is equal to X2. After we done the substituting, now we're going to get the new equation which is delta I in bracket T over delta in bracket T is equal to V in minus R times I in bracket T minus VC in bracket T over L. T is G in bracket T and X1 and X2. For the new value of X1, X1 is equal to X1 plus in bracket F1 plus F4 close bracket plus 2 times in bracket F2 plus F3 close bracket over 6. And then for the new value of X2, X2 is equal to X2 plus in bracket G1 plus G4 close bracket plus 2 times in bracket G2 plus G3 close bracket over 6. For the value of H, the H is equal to Tf minus T0 over N. Here you can see that H is the step size, Tf is the final time, and T0 is the initial time.